Join us at The Hedge for a conversation about engineering, technology, and business.
In this episode, Russ White and Pavel Odintson dig into FastNetMon.
Hi, Pavel. Let's see, where are you in the world and what time is it there? I always get lost.
So my time is 7 p.m. I'm in Britain, especially I'm in East London.
Okay, East London. All right, cool. So, I have lots of memories of London, actually, from my ETFs, and going to Rye to see some friends, and then going to Reading, and then Oxford once, and then, this, that, and the other, going to Madame Tussauds and riding the Eye, all that kind of stuff. Yeah, it's kind of cool. London's a great place. So this week on The Hedge, I think this will be episode 10 is what this will be. I looked at my calendar and that seems to be what it would be. We are talking about FastNetMon. So let's begin with the beginning and maybe talk a little bit about what FastNetMon is, because a lot of people listening to this probably have never even heard of this little software project.
Let's start. I can describe from my perspective FastNetMon as DDoS detection software, because main purpose of FastNetMon to confirm when you have some issues in your network. FastNetMon is not focused on any remediation and any mitigation steps, but main purpose of FastNetMon to use all available information for network telemetry in your network, like IPFix, S-Flow, NetFlow, JFlow, all kinds of vendor-based ways to export information about traffic. And then FastNetMon can process this information and notify you or your APIs about case of DDoS against some of your hosts in your network. So it's quite basic idea, but for how many time of project exists, it's quite useful, because in case of DDoS, it's very important to understand what is the impact and what is the affected subnets, customers, services, and its main idea of FastNetMon.
Okay, so let's back up a little bit and talk about, you said a lot of things that you monitor. So BMP, is that on the table? Do you monitor BMP stuff from routers, or are you mostly focused on, you said S-Flow, J-Flow, NetFlow, things like that. So explain a little bit about what you're monitoring and how you're getting the information you're getting to see that there's a DDoS attack going on.
Sure. From historical reasons, when we started FastNetMon, we had lots of soft routers. And one of the first ways to capture traffic in FastNetMon is span ports, or airspan. So FastNetMon can read data directly from port on Linux or FreeBSD box, and in which way this information can be delivered using port mirror from switches or routers. It's quite popular way to capture information, but it doesn't scale, unfortunately, because usually you are short on ports and short on capacity. And next, we added support for S-Flow. It's quite popular way to export traffic information from switches. It's one of the favorite types of traffic capture, because in comparison with IPFix and NetFlow, it doesn't add any latency in detection. It's very important for DDoS. And of course, we support IPFix and NetFlow, all kinds of and all flavors of NetFlow. And so it's main ways how we capture information from
So you're doing a lot of packet level capture, a lot of transport level capture. So are you looking at TCP? What are you looking at? How are you seeing that a DDoS attack is occurring? What is the heuristic that you're using?
So in industry terms, FastNetMon is threshold-based detection engine. So main things what we expect from user of FastNetMon to specify baseline, to understand what is your expected traffic for this particular network. So from FastNetMon perspective, we offer multiple ways how you can specify different traffic expectations, thresholds for different services in your network. So, and FastNetMon can collect information from all available ways. So you even can mix information received from S-Flow, NetFlow, IPFix, and port mirror in the same instance of FastNetMon. after FastNetMon will check what is the direction of traffic in this case. So is it incoming or it ongoing? And then FastNetMon will allocate counters for many different kinds of traffic, like number of packets per second, number of TCP packets per second, number of fragmented packets per second. And when this value crosses a specific threshold, FastNetMon will trigger script or send email or create BGP black hole or just BGP announce a specific community, and then you can use it for your infrastructure and what's intended behavior in this case. So you can use scribing center redirection or using your own filtering boxes. So it's up to you in this case.
Okay, so that's interesting. So you're doing threshold based. So the thresholds are you checking like half opens as well in TCP, or are you only counting strictly the amount of TCP traffic that is going through the link?
So we have few additional counters for TCP. So we have a global counter about just total number of packets. We have counter for TCP packets, and we have more fine-grained counter for number of TCP SYN packets.
Okay. All right. So SYN packets. Yeah.
Yes, exactly. And we focus on levels L3 and L4 because we are trying to work on all available capture engines. And so from NetFlow perspective, you can receive much more information like about what is the kind of HTTP traffic or what else. And that's why we focus our tool on the levels L3 and L4. So,
okay. All right. So are you seeing a lot of impact from encryption on your ability to measure this, or is this kind of orthogonal to what you're doing in terms of just strict packet counts and stuff like that?
So from our perspective, we have no difference what is it encrypted or not. But to be honest, we had number of reports and it was quite challenging for us because, for example, we started seeing lots of UDP traffic over for protocol quick from Google. And because many networks rely on threshold-based and alignment with quite low expectation of UDP traffic, it makes DDoS detection more challenging because previously you can set quite low threshold for UDP traffic, but when you see big CDN network pushing lots of traffic over UDP, and it makes configuration more complicated. So in this case, you have to whitelist some kinds of traffic or align your thresholds with more precision. Yeah.
Okay. So it doesn't automatically set thresholds, right? It's something that it's not like it takes a moving average or anything. It's something that you manually set as a network operator. Is that correct?
So not completely. So by default, of course, you have options. So because I had conversations with many network engineers, and many of them completely understand what is their expectation of emergency level of traffic. So they know like amount of traffic. So for example, 2 million packets per second toward our network, we will start degrading or routers or switching cores, and so it's our emergency threshold. But FastNetMon, in addition to just detecting DDoS, FastNetMon also can export lots of information about your traffic levels for all your hosts, all your networks, or your different entities. So, and all time you can export traffic about how many traffic of UDP you have for this specific /32 host. You can check this information in Graphite, in FluxDB, in Grafana, and then we have few scripts. It's not, I cannot say that those scripts are production ready, but so you can try them and they can generate thresholds for you. So according to, for example, on historical information of your traffic for last 7 days. And so yeah, you can use this information in alignment and provide ways to automatically configure. So instead of just hard coding and
right. But now is that dynamic when you use those scripts? Is that what you're saying? You can actually dynamically use those scripts to set it like over every 7 days it resets, or every day it resets based on the 7-day moving average? Or is it something where you run the script and then you like take the information from that script and then set it yourself?
So this script can work completely automatically. So it's up to you how often you can run it, and also you can change formula, use it for configuration, for example. So you or this tool checks average and something like a 95 percentile of traffic, but you can adjust it. So if you want more precise detection, or you can just change. So if you care or don't care about specific traffic types, you can exclude them from processing. Yeah, but by default, it works completely automated way. So you can just run it every day, every week. It's up to you. But from my perspective, I can suggest all time to make some kind of reviews, because you may experience DDoS in the same time. You may experience like /dot effect, and then your data will be quite far low or far big for precise DDoS detection.
Okay, good, cool. So you said something about configuring BGP. So what does it do in terms of BGP? Does it use one-on communities? Is there something you've got to arrange with your provider? How does this piece work of it? I mean, what are the options in the BGP world, I guess, is my first question.
So from FastNetMon project perspective, we are trying to avoid some predefinite solution for you. That's why we support multiple BGP daemons. So we have support for Quagga, we have support for ExaBGP, and we have support for GoBGP. So all of them have different benefits, different disadvantages. And I suppose it's mostly if you use this one already in your network, you are going to use this one. And from FastNetMon perspective, what we can do from FastNetMon, we have complete support for ways to specify custom community. We have options to announce affected prefix or affected host, or specify or announce both of them. So, for example, if FastNetMon detected DDoS in UDP fragmented packets toward your host, something like 123/32, it will create BGP unicast announce for this host itself, a specific community. Also, in same time, it can generate announce for network which includes this host. Like it may be /24, it may be a bigger network, and it can announce it with different community. So that's what we can do from BGP unicast perspective. But also we have support for BGP flow spec, because BGP unicast, it's mostly suitable for cases when you can block some specific host completely. So, for example, in case of emergency, to save whole network and keep your network running, you can sacrifice multiple hosts and block them for some time. And in this case, you can use BGP black hole. So you can use community 666 on your routers and discard all incoming and outgoing traffic towards this host. And also, if you have support from your ISP, and you are a lucky guy if you have, because in many cases, unfortunately, it's not available, you can pass and expose exactly the same information to your upstream. And then all traffic towards your affected prefix by DDoS will be filtered out and block it on upstream side.
Okay, so how are you interfacing with these different BGP implementations that you have, that you've just listed? You say GoBGP, Quagga, which, I would say FR routing, but anyway, Quagga, and then you said ExaBGP. So how are you interfacing with those? Is this like a Yang backend, or are you like kind of screen scraping, modifying things?
Actually, it depends, because for ExaBGP cooperation, we use ExaBGP's API. It's quite simple. I cannot say it's like JSON REST. It's like you open pipe and then you push announces one by one, or if you have prefix announce, then you announce it in network, and if you have prefix withdraw and then prefix, you will remove it from your network. GoBGP is more sophisticated, because one of the main points of GoBGP, it's developer friendly. It's not for only network administrators. It's more focused on developers, and they provide quite good interface for interaction with different tools. And they use gRPC and on top of protobuf. And in this case, FastNetMon use their API on top of this one, and then we create special message, pass it to GoBGP, and then GoBGP implements all announces or withdrawals, what we're asking for. And for Quagga, we use just callback script, because in addition to creating BGP announces or sending email, FastNetMon can run script It may be Bash script, Python scripts, maybe even C++ application. And in this case, it was community contributed implementation, and we just call Bash script, which creates different arguments and makes call for Quagga to announce this new prefix and reload configuration. That's how it works.
Okay, excellent. And I'll just, have you considered using FR routing? Because the FR routing has a full Yang interface, OpenConf interface. Well, it's not really OpenConf. It's actually its own Yang models into the BGP implementation there. So it might be interesting to think about that instead of using Quagga.
I think, yes, it should be one of the next steps from Quagga, because Quagga, it's quite old school
it's quite
software.
old.
It's very old school software, yes.
So you just run this BGP in a different container, or you're just running on top of Linux? I mean, this all runs within a container or bare metal on Linux, or how does this actually deploy for somebody who's trying to run it?
It's actually up to you, because FastNetMon is just like a tool set, and you can, because we have lots of different BGP backends, we have lots of different backends to export traffic, export all information. We have many options to expose this to external system. That's why we have no limits from ways how you deploy it. So you can deploy it in like bare metal on Linux. You can deploy it on bare metal on FreeBSD, OpenBSD, because for FreeBSD, OpenBSD, and Ubuntu Linux and Debian Linux, you can install FastNetMon out of the standard repositories. So it's not even required to download something from our site, to compile something. So you just use your package manager, select FastNetMon, click install, or just press enter button, and here you go. And so I spent lots of time to make it possible. It was really challenging, yeah. But it provides lots of benefits. And then you can deploy it just on bare metal. We also have official Docker images, so you can use it in containers. Lots of ways how you can deploy it. You can use Kubernetes deployment. You can use public cloud. So from our perspective, we are trying to be very open-minded for all new platforms, because from our experience, for example, we are very, very surprised when we just noticed that lots of people asking for support for Kubernetes. So because usually it's like something like from software development world, not from network and telco world, so it's growing, and it's becoming very popular to have like your own Kubernetes cluster for telecom companies, and it's exciting change.
Yeah, it's very interesting. Yes, so if you don't know Kubernetes, go learn it. In fact, I'm doing a Kubernetes course right now because I'm trying to learn it.
It's exciting. It's exciting.
Because the world is going that direction, whether or not we like it.
Exactly. Everyone going in this direction, and never network people.
Yeah, exactly. So how can you kind of break down what the modules are within FastNetMon, or is it just like one monolithic program, or are there different pieces of it that someone who's running it could dig into a little bit and understand it?
Yeah, sure. So when we started FastNetMon, we tried almost all possible language. If I remember correctly, but I may be wrong, first version of like proof of concept was implemented in Python. Then we noticed some issues with packet parsing in Python. It was quite slow, and then we tried switching.
Imagine that.
Yes, exactly. Because you remember, first thing we tried to add in FastNetMon is options to capture traffic from port mirror. And so it was something like about 1 million packets per second. It was quite challenging. Then we switched it to Perl. For some reasons, it was quite fast library for packet processing, but then we have got lots of issues with like multi-processing. Next thing we considered using Go language, but at times when FastNetMon started, it was 2013. Go language wasn't in perfect condition, didn't have lots of libraries and not so many experience also from our side. And that's why we started using C++, because it covered our expectations about performance. Only with C++ we were able to handle 1 million packets per second, and under DDoS condition it was about 2 or 3. And also we had some proof of concept tests with guys from SnapSwitch, and we achieved something like 56 million packets per second using C++ core. So it scales.
Yeah, no, it scales. That's good. So you're using C++ and you're using direct to kernel, or are you pulling off of a NIC, or how are you pulling the traffic in? Like, if I had a Broadcom-based box, could you pull off of SI, or is it strictly coming off the kernel, or how does that piece work?
That's a really amazing question. So I have lots of discuss for this particular case. So because, for example, we use standard stuff for NetFlow, for IPFix, and for SFlow. Because usually amount of packets, it's not so big, like it's maybe 20,000, 100,000, but it's not a big deal for Linux network stack. It can handle it easily, spread over multiple threads, multiple cores, it's fine. But when we are talking about ways to capture traffic, and especially on line rate on 10G, 40G, on 100G, it's absolutely different story, because any naive approach to just receive this packet, process it, it doesn't work. You have to use lots of tricks. And one of the first capture engines added in FastNetMon, it was PCAP. It's exactly the same technology as TCP dump based on.
Right.
It scaled quite well, but we discovered some limits on something about 200,000 per second. When you use all cores on your machine and you just don't have any options to process more, but you have much more traffic and you cannot afford dropping 80%. So it was our first attempt. It was no-brain solution. So if you're looking how I can capture traffic from network card, here you go, you have pickup. And next thing what we tried, and we were very happy, it was PF Ring. It's kind of commercial technology, and it's kind of open source technology, because they offer PF Ring standard. It's completely open source, and it's absolutely free, but it scales up to 1 or 2G. And if you want more, you have to pay for PF Ring 0 copy. And then you can enjoy 10G line rate, 40G line rate, and something like half line rate on 100G. And you can use exactly the same interfaces. And we were very happy about it, so because we are open source, and it's very important for us to provide some solution which works quite well. And for very, very, very long time, for port mirror capture, we used PF Ring as default option. But things changed recently. And next things what we added in FastNetMon, so most of the time we were based on PF Ring, but we noticed some issues with PF Ring, because FastNetMon supports, if I remember correctly, 15 different Linux distributions, and unfortunately all of them use slightly different kernel versions. And from PF Ring perspective, it works really well, but they have official support for standard kernels in CentOS, for standard kernels in Ubuntu, but if you use Gentoo, Arch Linux, SUSE, and in this case, your kernel version will be a little bit different, and you cannot use PF Ring. And then we started looking at options for how we can do it without using any external libraries, because PF Ring, it's like kernel module, like driver, and you have to go to site, download it, and install it, and it's still kind of challenge. And something like 4 years ago, we introduced support for AF packet. It's completely open source, of course. It's free. It's part of Linux kernel. So if you run quite modern kernel, it's from 2.10 or something like 3.10.
Yeah, that sounds right. Yeah, 2.10, 3 point something, right?
Yeah, and it works very well. It scales from our experience up to 10 million packets per second. It can spread traffic over multiple cores, multiple threads, and it works really great. So you just, because for example, for PF Ring, you need some configuration, something like buffer, like what else, but AF packet works really well. So you just started, and it works. And we had 2 or 3 bug reports from AF packet, but all of them were times when AF packet was quite new technology, because in recent versions of kernel, I'm saying recent, 2 years ago, developers did lots of changes. They touched almost every part of AF packet code and improved it a lot. So, but unfortunately, we were still limited by quite old distribution, because, for example, for CentOS 6, we still use PF Ring. because kernel is so old and we cannot afford using KF packet because it's kernel 2.632. It's extremely old, and only one way how you can do it is PF or PF ring. And I think CentOS 6 is last distribution for which we support PF ring. For if you run youth distribution and you are quite happy guy, so you can use AF packet. So because AF packet is a really great technology, because when you install something from official repositories of Ubuntu or Debian, you cannot package any commercial code. And in this case, in particular in PF ring, you have to visit official site, download something, configure something, and it may be quite challenging for you. But AF packet, it's open source, available in Linux kernel. It's not required to change Linux kernel, configure it some way, just start it, and it works. But unfortunately, AF packet had lots of, I don't think lots of, because for many cases, as I said, up to if you have something like 10G of traffic or 40G loaded by 20-30%, it works really well. But if you are looking for something like, okay, we have line rate on 10G, or we have about 2 line rate on 40G, and here you go, you can use new, very fancy technology from Linux kernel, because according to experience in different packet capture engine, because in addition to PF ring, in FastNetMon we used NetMap. NetMap is well known in FreeBSD community because NetMap is default in FreeBSD kernel, but for Linux, unfortunately, you have to compile it manually, patch drivers for network cards. It's quite sophisticated. And so many people had similar issues, and then team of people from different companies, from Red Hat and Intel, they started development of new technology in Linux kernel. It's named AF_XDP. And it's like NetMap, PF ring, because it implements zero-copy approach, and you can read traffic without multiple memory copies on really
so that makes it a lot faster. Yeah, that makes it a lot
faster. Yes, yeah. And on exactly the same hardware, when we can achieve something like 4 million per second with AF packet, with AF_XDP, we can achieve something like 12 and sometimes 14. And it's a really, really good technology. It's a big step forward, and it's already available in many fresh distributions. For example, if you run Ubuntu Linux, you can install kernel upgrade. And if you can install kernel like 5.0, you already have these features enabled, and it's implemented for many high-performance network cards from Linux, from Intel. And you already have all batteries included. So you can just download standard Ubuntu, install FastNetMon, and here you go. You can get almost everything from your network card.
Wow, cool. Good.
It's really exciting.
Yeah, it is. That's really, really neat. So just to recap a little bit before we shut down and plan another podcast to talk about, another episode to talk about use cases and go into a little bit more detail perhaps. So FastNetMon is open source. You can just go to the Linux repository, download it, install it on standard Linux implementation or distribution, run it, and you can either do packet captures and or use any of these other methods, SFlow or something IPFix, to grab the data, and then it's going to do threshold-based DDoS detection, which in the next time we talk about this, I want to talk about all the use cases for that, because we want to think that's really focused on my network edge, but there's actually a lot of other places you can use this, and then it'll feed back through other systems using GoBGP or XOBGP to allow you to modify your BGP advertisements to redirect traffic or do whatever using communities. Exactly. So Pavel, where can people find you, and where can people do you blog or anything, or are you kind of silent on social media?
So you can find me on Twitter, but I don't post so much information. I think one of the best cases to subscribe for FastNetMon mail list. And then you may read some announcements about new features, what's going on in the FastNetMon project, updates about new releases. And we have quite strong community, because right now at mail list we have about 2,000 people subscribed. And sometimes what makes me happy when people ask for something with FastNetMon, somebody else sorted the problem. And okay, it's fine. Thank you, guys.
Yeah, so it's a real community. It's not a small group. It's actually a large community, and it's doing a lot of good work. Great.
Exactly. And we have lots of ways how you can reach me. We have a Telegram group, we have Slack group, we have IRC on Freenode. It's just FastNetMon. So
excellent.
We have lots of ways how we communicate, because from first times when we start FastNetMon, it's based on customer experience, customer feedback, advices, ideas, just proof of concept. So
excellent. All right. Well, thanks, Pavel. And we'll bring you back on to talk again about FastNetMon, because this is pretty fascinating, particularly for frontline network engineers who are working on, real world problems of trying to solve some of this stuff. And again, we'll work through some of the use cases and stuff. So thanks for joining us. And thanks, Pavel. And we'll bring you back on. Thanks.
Thank you. Bye.
Thank you for joining us. You can find The Hedge at rule11.org.